Hey guys, welcome to today's video. If you've been following along, you already know what I'm working on. If not, I'm working on something pretty cool. So in my last series of videos, I was developing a toolkit that can take a picture, any picture that you have, and turn it into a Lego set. So for example, this picture here is taking this Mario image, just the stock Mario image, and it's outputting it as a Lego mosaic. So if I zoom out, you get a really nice mosaic effect. And all of this is rendered using real Lego blocks. And the numbers on here correspond to the actual color that you can buy on the Lego website. So with this plan, you could buy these really easily or get them from a kit and build this mosaic and hang it on your wall. And these things look awesome. I've built these. These things look so cool, and you're gonna get lots of comments. So anyways, that's the project that I already finished. So take a look at those videos if you're interested. But today, I was thinking, I had this crazy idea. I was like, well, okay, I've already got my computer vision projects. Like some of my older projects, if you look at them, we did things like like object detection in World of Warcraft and stuff like that. So, you know, just to give you an idea, that's the type of videos that I've been working on. And I was actually getting ready to start another video series on creating AI that can play Super Mario visually. So I had this crazy idea. Is it possible to render my desktop as Legos? So that's what I wanted to work on. So I did kind of this prototype, and it came out really nice. So what I did was, if you've been following along with the other videos, you've already seen this code. This is the code that we wrote together on how to create the Lego plan. And I wrapped that in a, if you look at some of my older tutorials where we did the computer vision stuff, this is my MSS, using MSS as an input, as a screen capture. So anyways, all I did was I took this MSS loop that's going to capture the video from the screen, and I basically brought in my Lego functions, pixelate and make Legos. So if I run this code, it's going to spawn a window that's going to start screen capture, and it's going to turn those into Lego blocks. So this isn't just pixels, this is actual Lego blocks. So you could actually go out and build this Lego set. So for example, here's my terminal and my desktop, and I'm going to slide this over. This is the preview window. And it's so cool because what we can eventually do is actually render this to the screen and create a Lego desktop, Lego block desktop. Or you could take your desktop and actually build it out of Legos. So that's really cool. Now there's one big problem with this. It's super, super, super slow. And I know what the problem is. It's not with the screen capture, it's with the way we did our algorithm for converting the color. So let me kill this and show you just how fast I want to make this thing. I'm going to comment, so I'm going to keep the pixelate function that we wrote because that's no problem, that's fast. But our Lego Maker function wasn't written in a very fast way. I'm going to rerun this code now, so it's only pixelating. So it's not calculating the colors for Legos, it's using native colors. And you can see that essentially it's near perfect. So if I do like NeoFetch, it's near like exactly the same as real time. So this is halfway there. So the problem that we have, guys, is with our code, when we do our Lego calculation, which is here, let's see here. When we're doing our color calculation, guys, we're using for loops. Now for loops on small stuff in Python is fine, but the problem with pictures is that when we get bigger and bigger and bigger, you go from a 720 to a 4K picture, the data exponentially gets bigger. It's not just double the size, or it becomes exponentially bigger, going from like a HD to a 4K. So the problem we have is the way we wrote this. So it's going to be too much for this video. We're going to have to do a series on how to fix this, but I really encourage you, if you're learning Python, I'm going to do so right here, this is the function Lego Maker, and here's the problem. What we're doing is we're looping through every pixel in our image one by one. So if you think about it, that's going to have a exponential slowdown as that image gets bigger. It's going to be O of n squared. If you're a computer scientist, you know what I'm talking about. Essentially, every time the image doubles in size, it exponentially gets slower. So if we have a really small image, it's fast. But once we get something bigger and bigger and bigger, like a screen, it gets too slow. Now, it works just fine for our previous project, which was, hey, generate me one image. But when I have a loop going and I want to capture my desktop live and show it as Lego blocks to a user, which would be really cool, it's got to be fast, and that is way too slow. So I'm going to start a video series on how to fix this. The first lesson that I'm going to be doing is going to be how to do what we call vector calculations and matrix calculations. So right now we're looping through this. There's an entirely different way to do this. It takes a little bit more thinking and a little bit more code. It's not as simple as just looping through the whole thing, but it is very fast. So much faster, it's unbelievable. So we're going to be able to speed this thing up. So if you're an intermediate Python user, this is going to be a really, really good video for you if you typically write your projects using for loops. Now, there's no problem with for loops in a lot of use cases. You know, if you have a small amount of data, you want to zip through it, no problem. But when you start looking at video in real time and we have to go through every pixel on the screen, it is way, way, way too slow. So we have to use better methods and algorithms and tools. And Python has a lot of tools. Python is notably slow. Everybody makes fun of Python for being too slow. It's not too slow if you program it correctly. In some applications, it is too slow. If you're doing finance and you need, or game engines, yeah, you're not going to use Python. You're going to use C or C++. But for most applications, you absolutely can use Python. I mean, why is Python being used in machine learning? Because there's so many wrappers that wrap C libraries, and that's what we're going to do. So we can get the best of both worlds. We can get the speed of C, the C language, or C++, but mostly it's C libraries, wrapped in Python. We can do our calculations that way. It's very simple. It's not very complicated. It's not like we're going to be writing C code. We're still going to be writing Python code, but we're going to have access to those underlying libraries. It's going to make our code much, much faster. So that's the problem with our code. So I encourage you, if you're an intermediate Python coder, you're comfortable writing object-oriented coding, you're comfortable writing a for loop and going through an array, but you struggle with, okay, how do I make stuff real fast in Python? You're going to really like this next series of videos, because we're going to focus on just taking this small function here, and instead of looping through this image, we're going to figure out how to make this thing super fast. So that'll be a really good learning experience. And if you're a beginner at Python, you can still follow along. It won't be too far over your head. But I think a lot of intermediate Python users, we tend, if I'm guilty of this, as a matter of fact, this code proves it. I like to throw for loops into my code because it's so quick and so easy. But if we take a step back and do it a different way, we can make our code really fast and efficient. So I look forward to seeing you in the next video, and we can get started on this project. And keep an eye out for my next series, coming up as well. We're going to be creating a Super Mario AI. So we're going to be using computer vision, kind of like this. We're going to have our game monitoring the screen, monitoring our Nintendo, and we're going to be teaching an AI how to play Super Mario. So we're not just going to be, hold the A button for 3 seconds, let go. No, we're going to actually identify objects on the screen and all that. But we're actually going to need to use a lot of those same principles, because we're going to have fast code if we're going to do that for the exact same reasons. So that's why I think this is actually a really great project. This Lego project actually turned into a couple of really important mini projects that are very useful. So I look forward to seeing you in the next video. And if you haven't, consider liking and subscribing. I appreciate it, guys. See you later.